Hi, welcome to my channel. In this video, you're going to learn about simplifying radicals. But before that, please don't forget to subscribe to my channel, share my videos, and like if you like it. So now, let's simplify radicals now. So I have here number 1, the cube root of 48. So we have the index here is 3. It means that we're going to find one of the factors of 48 that is a perfect cube. So if you don't know your um, set of perfect cubes, you can do prime factorization. So 48 is 8 times 6. Actually, 8 is already a perfect cube. Let's say you don't know about that. So now, you can still multiply that as 4 times 2. And then, 4 is 2 times 2. And then we have 6 here as 2 times 3. Now, when we say perfect cube, of course, same number multiplying 3 times. So we have here, that's 8. That's why it is a perfect cube. So what are you going to do? Okay, so you can either rewrite 48 as 8 times 6 and get the cube root of 8. Or you can write it all like this. Just enumerate all the prime numbers that you have here. So now, when we say cube root, that number is being multiplied to itself 3 times. So we are going to get this. That is 2. That number is 2. Which means that 2 times 2 times 2, that is 8, means that the cube root of 8 is 2. Now, we have remaining numbers here, 2 and 3. So we're just going to multiply that because they are not perfect cube and they should be remain inside the radical sign. So 2 times 3, that is 6. So the final answer now, the simplest form of the cube root of 48 is equal to 2 times the cube root of 6. Now, what about for the fourth root of 32? So take note of the index always. So 32, if you're going to use prime factorization, you will end it up like this. So that is the fourth root of 2 times 2 times 2 times 2 times 2. That's 32. So since this is 4, it means that number multiplying to itself 4 times, so we are up to this one only. And it means that the fourth root of this is simply 2. Or what is this number? 2 times 2, 4 times 2, 8 times 2, 16. It means 16 is a perfect fourth root of this. Is equal to the fourth root of 16 is 2. And now, we have here the remaining number 2. So you can write that inside the radical sign. So the simplest form of the fourth root of 32 is equal to 2 times the fourth root of 2. So now I have here the cube root of 80x squared. Now, if you're going to use prime factorization, for 80, we know that 80 is 8 times 10. And for 8, we know already that 8 is a perfect cube. But let's say we still need the last, or we need to have all the endings be a prime numbers. So we are going to, again, 4 is not yet a prime, so that is 2 times 2. Sorry about that. Okay, so we have for 2. Okay, so what we have now here, how many 2's do we have here? 1, 2, 3, 4, and then times 5. So that is now 80 is equal to 2. 2 times 2 times 2 times 2, and then times 5. Now, we can write it there. So, since the index here is 3, we just need a number multiplied to itself 3 times. Okay? So, it means that that is 2 times 2 times 2, that is 8, and that's the cube root of that is equal to 2. And then what we have left here is 2 times 5x squared. Okay? So that is now 10x squared inside the radical sign. Why? Because x squared is not a perfect cube. So that's only x times x. So a perfect cube should be multiplying itself 3 times. So now, let's have number 4 here. The fifth root of 243, then x to the 7th power, y to the to the 5th power. Okay, so now we have here 3 times 3, if you're going to use prime factorization, times 3 times 3 times 3. And then, x to the 5th power times x to the 2nd power. Why? This is x to the 7th power. So I can factor this as x to the 5th and x to the 2nd. If we're going to add this, that is equal to 7. And then, y to the 5th. It's already, the exponent is already 5. Okay, so it means we're just looking for a number that is multiplied by itself 5 times. So here, 1, 2, 3, 4, 5. Okay, so this one, it means 243 is already a perfect for this index 5. So that is now 3. And then we have here x, fifth root of x to the 5th power, and that is x. And then we have the fifth root of y to the 5th power, and that is y. So that's why we have x and y, and it should be outside the radical sign. So what is left inside now is x squared. So that is now 3xy times the fifth root of x squared as the simplest form. Okay, now I have here the last one here, the fifth root of 120x to the 8th power y to the 5th power. So this is now the prime factors of 120. So you notice here, there is no factors here or prime factors that are multiplied to itself 5 times. Which means that because the index here is 5 and this is only 1, 2, 3. So which means that the 120 is already a simplest form. So what we're going to do now is remain inside the radical sign, the 120. So that is fifth root. Sorry, I forgot to put here. Should be the fifth. The index is 5. And I have here x raised to 8 power. I can rewrite that as x to the 5th power times x to the 3rd power, and then the y cubed. So the only thing that I can simplify here is fifth root of x to the 5th power, and that is x, and the fifth root of y to the 5th power, which is y. So I can bring them outside the radical sign. So I have now xy. So I have xy times the fifth root of 120x cubed. That's the simplest form. So that's how you're going to simplify radicals. Thank you for watching and see you in the next one. Bye.